Today we will be in Chapter 3, Section 1, Changing Application Problems into Equations, and our three topic objectives for today will be to translate phrases into mathematical expressions, to express the relationship between two related quantities, and to translate applications into equations. Okay, today we will be in Chapter 3, Section 1, Changing Application Problems into Equations. And for this section, I created a handout that kind of works as your notes and some fill in the blanks. So we need to get that open so we can work through it. So what you do is you get into your Course Compass or My Math Lab site, and you go over to the left-hand side where it says Course Documents/Videos, and you click that, and then below that you'll see another button called Handouts. And once you're in there, you'll see there's a handout for a couple of different sections, but we want the one for 3.1. So once we get that open, you will see that I've created this nice little handout, and this is going to work as your notes and as our kind of as we're working the problems. So Chapter 3 is all about word problems, and I know a lot of you probably don't like word problems. I guess the bright side is that this chapter is only 3 sections long. So hopefully we'll get through it without too much pain, but let me stress to you the importance of learning how to do word problems, because you're going to see them in every math class from here on out. And if you learn how to do word problems, it's going to make your science classes easier, because then you're going to be able to read that information and translate it over. So it really does come in handy. But for 3.1, one of the first things that you have to learn to do in order to do word problems is we have to learn how to translate phrases into mathematical expressions. And so this table that I have made for you is to show you how to do that and kind of which operation goes with which words whenever you're reading your word problem. So if you're looking in the first section of this table, you're going to see that all of this has to do with addition. And so you're going to read words and phrases in your word problems that are like added to, or more than, increased by, or the sum of, and those all mean that you're going to do addition. And so then I gave you some sample statements, like 8 added to a number, and if you see that that's going to be translated over to the algebraic form of x plus 8. You're taking 8 and adding it to some number, and we don't know what that number is, so that's our x. If you look, there's 6 more than a number, so that's going to be x plus 6. A number increased by 3 is going to be x plus 3. And the sum of a number and 4, the sum implies addition, so that's going to be x plus 4. If you look at the second section of this table, you're going to see that all of these have to deal with subtraction. So those are going to be words or phrases like subtracted from, less than, decreased by, or the difference between. If you're reading a word problem and you hit one of those phrases, that means you're going to be doing subtraction. So there's a couple of example statements. There's 6 subtracted from a number, 2 less than a number decreased by 5, and the difference between a number and 9. And then there's the algebraic forms of all of those. The third section of this table is all about multiplication. So these are going to be words or phrases multiplied by, the product of, twice a number, or 3 times a number, or 4 times a number, etc. Or of when used with the percent or fraction. So some example statements of that is a number multiplied by 6 is going to be 6x. The product of 4 and a number, 4x. Twice a number, 2x. 3 times a number, 3x. And then 20% of a number, that'll be the 0.2x, because you have to translate your percent into decimals. You did that back in chapter 1 as well. And then the last section of our table is all about division. And those are going to be phrases divided by or the quotient of. So a number divided by 8, that'd be your x divided by 8. Or the quotient of a number, and 6 will be x divided by 6. So hopefully this table will really help you to be able to zone in on the important words inside of your word problems so that you can do these a little bit easier. Okay, so let's do a couple of examples. I'll try and leave the box or leave the table up there as well. We'll do some examples. So we get the height, and it tells you h, so it wants you to use that as your variable. So the height h increased by 4 inches. So increased by, if you go up to our table, that's in the addition section. And so if you look, we have an example statement, a number increased by 3, that would be x plus 3. So in this case, we have the height increased by 4, so that would just simply be h plus 4. Okay, so the second example is the age A decreased by 5 years. Okay, we have decreased by, and that is in the subtraction column. So if you look at how those are done, the age A decreased by 5 years should be A minus 5. Example 3 says 7 times the length, which is L. And when you have a number times a number, that's multiplication. So your answer for that one should be 7L. The fourth example, M subtracted from 8. Well, right there you know it's going to be a subtraction. So when you do that though, which number comes first, the M or the 8? And this is where it can get confusing. This says M subtracted from 8. So since it's from something, that from comes first. So the 8 is going to go first, and then you're going to have minus M. That can be the one confusing part of doing subtraction, because you don't know which number comes first unless you think through it a little bit. Okay, the last one says 1/3 the weight W. So 1/3 of the weight, I guess I should have put the word of in there so that it would tell you that you're going to be doing multiplication here. So 1/3 would be 1/3, and then of the weight, that means you'd put a W. So it'd be 1/3 W. Okay, let's move on down. Okay, this says statements can contain more than one operation. So here's an example statement. It says 4 more than twice a number. Okay, so the 4 more part is going to be addition. You're going to be adding 4 to something. And what is that something? It's twice a number. Twice a number is under our multiplication section. That would be 2x. So that becomes 2x plus 4. You can do one algebraic property, or you can do more than that in a single line. Our second statement says 5 less than. So 5 less than should tell you subtraction. And then the 3 times a number, again, 3 times a number would be in our multiplication. So that would be 3x, and then 5 less than that will be a minus 5. Okay, let's read the next one. It says 3 times the sum of a number and 8. Okay, so we know we have 3 times something, but we don't know exactly what yet. So the sum, if you look back at your table, would tell you addition. So you're doing the addition of a number, so that'll be an x, and 8. So that means you're going to have your x plus 8, and you're going to multiply that all by 3. And you get that algebraic form on the right. Okay, the last example here says twice the distance, or the difference between a number and 4. So if you're looking up at your chart, the difference means subtraction, and it says between a number, which will be our x, and 4, so you're going to have x minus 4, and then you're going to have twice that. So you have 2 times x minus 4. So these statements can be more complicated, but hopefully between these examples that I've given you right here and the table from above, you'll be able to dissect them and be able to get them over to the algebraic form. Please let me stress the importance here of repetition. So when you're doing your homework, you're going to need to keep doing the similar exercise button so you can get some added practice, because the best way for you to get used to reading math and translating math from words into algebra is for you just to do a whole bunch of them. And I know that's probably not what you want to hear, but it really is the truth. Okay, let's slide on down to page 2. It says, note, there is more than one way to state the same algebraic expression. Okay, and just like up in the first table, which I'll zoom back up, just like up here we had more than one way to say addition and more than one way to say subtraction, we're going to have more than one way to say a specific algebraic expression, and that's okay. So here's some examples of that. In the algebraic form, we have 2x plus 3. So there's a whole bunch of different ways that could be said in words. That could be said as 3 more than twice a number. That could be said as the sum of twice a number and 3. It can be said as twice a number increased by 3, or even 3 added to twice a number. All of those statements give you the algebraic form of 2x plus 3. Okay, the second example is 3x minus 4. So that's your algebraic form. Statements that could give you that would be like the example shown. We have 4 less than 3 times a number, or 3 times a number decreased by 4, or the difference between 3 times a number and 4, or 4 subtracted from 3 times a number. All of those statements will give you that same algebraic form. So it's good for you to get familiar with all the different ways that you could be reading a problem and it give you the same thing. Okay, and we're going to do some examples. So let's look at example 1. It says 8 more than twice a number. So if you're looking at the 8 more part, that's going to be addition. And then 8 more than what? Twice a number. So that'll be 2x. So you can write that as 8 plus 2x. Or if you wanted to, you could write it as 2x plus 8, however you want. I usually put my things with my variables first, so I'll probably write it as 2x plus 8. But either way is correct. Example number 2 says 4 less than 5 times a number. So the 4 less than tells you you're going to be subtracting 4, and the 5 times the number part will tell you that you have 5x. So your final answer should be 5x minus 4. The third example says 1 more than 1/2 of a number. So 1 more than should be telling you plus 1. You're going to add 1 to something. And that something is the second part of that statement, which says 1/2 of a number. So you should have 1/2 x plus 1, because you're taking 1/2 times your number, which is your x, and you're going to add 1 more to that. Okay, the next example says 1/5 a number decreased by 7. So just like above with the 1/2, only this time you're doing 1/5, so you're going to have 1 over 5 x, and then decreased by 7, that means minus 7. Okay, the last example. This says 6 more than 3 times a number. So you have 6 more, which should be addition, and then you have 3 times a number, so that will be 3x. So this again can either be 3x plus 6 or 6 plus 3x, however you like. Alright, let's move on. Let's express the relationship between 2 related quantities. Okay, some examples of what I mean by this is, it says 2 numbers differ by 5. Okay, so we don't know either of these numbers. So that means we need to let one of them be an x, and then the other number is going to be, it says differs by 5, so it needs to be 5 more than the first one. So the second number is going to be x plus 5. Okay, these are a little bit harder because you kind of have 2 things you don't know, but it's going to give you enough information to figure them both out. Okay, so the next statement says Mike's age now and Mike's age in 8 years. Okay, you don't know Mike's age now, but we can let that be x, so that'll be our first number. And then Mike's age in 8 years will be whatever his age is now plus 8 years. So that's how we know the second number would be x plus 8. The next example says one number is 6 times the other number. Okay, so we let one number just be x because we don't know what it is. And then the other number is 6 times that one, so that would be 6x. Okay, and the last one is pretty important because you're going to have problems that look like this elsewhere. So it says one number is 12% less than the other. Okay, so you have one number, which will be your x, and then the other number is 12% less than that. So the confusing thing about doing percentages, especially when you're taking it away, is that you have to have the whole thing first. So you have x minus and then 12% of x. And the reason why you have it x minus the 0.12x is because when you take x and you multiply it by the 0.12, that is just giving you that 12% of that x. So it's not telling you that, whatever is taken away. So that can be confusing. We do word problems in the next section that have to deal with this, and it makes a lot more sense there than it does right here. But I wanted to show you how to come across these. Okay, so to do some problems with these, let's do the examples. And it says for each example, determine what to let x equal. Okay, so it says Mary weighs 15 pounds more than Sue. So this is all in general terms. So what would x equal in this case? Would x equal Mary's weight or would x equal Sue's weight? X would equal Sue's weight because we're going to take Sue's weight and add 15 pounds to get Mary's. So that should be Sue's weight. The next example says the length of a rectangle is 4 inches more than twice its width. So what would be our x in this case? It would be our width because we're going to take 2 times our width and then add 4 inches, and that'll give us our length. Okay? The third example says Joe earns $56.20 less than Larry. So if we were solving this problem, our x would be Larry's pay, because you're going to take Larry's pay and subtract $56.20 from it to get Joe's. Okay, last example. The theater sold 525 tickets. Some were adult tickets and some were child tickets. So what would our x equal in this case? Okay, this is kind of a trick question, but I threw it in here because you do see it sometimes. X could equal either the adult tickets or the child tickets. We don't know enough information just from the information that they gave us to determine either of those. So it could be either the adult tickets or the child tickets. Okay, let's move on to page 3. Hopefully you're not getting too lost. I know that this is a lot to take in, which is why I made this handout the way that I did, so that you can keep going back and looking at it. Okay, the truck rental example. It says Maria rented a truck for 1 day. She paid a daily fee of $38, and then she had to pay a mileage fee of 25 cents per mile. We need to write an expression that represents her total cost when she drives X miles. Okay, so we're not actually writing an equation in this case. We're just writing an expression because we won't have an equal sign or anything like that. But we need to figure out what that would be. So it says she paid a daily fee of $38. So that means regardless of if she drives the van or not, she's gonna pay $38 for every day. So you should have a 38 plus. And then how much does she pay per mile? She pays 25 cents per mile, and it tells us to use X as our miles. So we should have 0.25X because we don't know how many miles she's going to drive. So that should be our expression. She's going to have 38 plus 0.25X, and that'll tell her how much it's going to cost to have the truck every day. That's a lot like how your problems are going to be today on your homework. They're going to be like that, and then you might have to solve them. Okay, let's go on to the next box where it's translate applications into equations. So this is pretty much what we've been doing, only now instead of just getting expressions, we're actually going to get equations. So we have equal signs. These are things that we can actually solve in order to get an answer. So the first statement says 6 times a number is 42. And I bolded that is because anytime you see the word is in an equation, it's going to be an equal sign. And so right there, you know you can put an equal sign in. So 6 times a number, just like from above, will be 6x. Is will be an equal sign, and 42 is just the next answer. So you should get 6x equals 42. Okay, the next one says 5 more than twice a number is 4. So 5 more than should tell you you're going to add plus 5. Twice a number will tell you 2x. Is an equal sign, and then 4. Okay. I don't really want to read all of these because I think you're able to read this table and kind of see how they all flow together. I try to do one of each type though for you so that you can kind of see how they all play out. And I am color coding them all right now for you so you see where each part is coming from. And you can always pause the video here and work through these in your head or on your paper if you need to. Okay. Let's move on to this bottom part. And I had to address this because this does come up on some of your homework problems, which I will do a few of your homework problems here in just a few minutes with you. But here's some definitions. We are going to have things called consecutive integers, and these are integers that may differ by 1 unit. So an example of these is the number 5 and 6. Those are consecutive integers. They come right after the one in front of them. So 6 and 7 would be -3 and -2, 0 and 1. Those are all consecutive integers. And these may be represented as x and x plus 1. So if you're asked to find 2 consecutive integers in a problem, then you might be doing an x and an x plus 1 type of problem. Okay, the next type of integer you could have is consecutive even integers. So that'll be like 6 and 8, or negative 10 and negative 12, or 46 and 44. It's just two even integers back to back. So 2, 4, 6, 8, those are all even. Those are all consecutive integers to each other. So these are integers, even integers that differ by 2 units, and they may be represented as x and x plus 2. The last type is consecutive odd integers. These are exactly like consecutive even integers, only these are your odd numbers. So these are 7 and 9, negative 11 and negative 13, 53 and 51. These are odd integers that differ by 2 units, and they may be represented as x and x plus 2. You will have a problem like this on your homework. And so actually, I'm going to work a few with you right here. And it says, these are exactly like the ones on your homework. I actually forgot I had this page on here, so I will not be working homework problems with you because this page is all homework problems. Okay, so let's do them. It says write the problem as an equation. So for 2 consecutive even integers, the sum of the smaller and 3 times the larger is 22. Okay, so 2 consecutive even integers, that we just said was the x and the x plus 2. So those are going to be the 2 variables you're going to have. You're going to have x and x plus 2. So our x will be our smaller number because we need to take 3 times our smaller number and add the sum of the smaller and 3 times the larger number is 22. So x is our smaller number because then you add 2 to it and you get the larger number. So you should have x, the sum of means addition, so you plus 3 times the larger number, so you should have 3, and then in parentheses you need the x plus 2 because that's your larger number, is an equal sign, and then 22. These, this said just write the equation, but if you actually had to solve this, you could solve this. You could distribute your 3 in, so that'd give you x plus 3x plus 6 equals 22. And then you could combine your like terms, which would give you 4x, subtract over that 6, and that equals 16. So your x would equal 4, and that's your smaller number. Your larger number is x plus 2, so that would give you 6 for your larger number. So you didn't have to work through that one because it said just write the problem as an equation, but you might be asked to actually solve some of these, and so I just wanted to show you that you can solve these if you wanted to. Okay, let's do another consecutive problem. It says for 2 consecutive odd integers, so that's going to be x and x plus 2 again, the sum, which is addition, of the smaller and twice the larger number is 37. So we're going to take our smaller number, add twice the larger number, and we're going to get 37. So if x is our small number, we'll have x plus 2 times our larger number, which is our x plus 2, is an equal sign, and then 37 is just 37. If you wanted to, you could continue to work through the problem and get your answers, but you don't have to. You do have problems just like those two on the homework and on the quiz. Okay, so let's do the last 3 examples. Again, these are exactly like the ones on your homework, which is why I have them on here, because I wanted to make sure and work through an example of each of these with you. Okay, so first we have the age equation example, and for each of these we need to write the equation, and then I'm going to actually solve these and so you can follow along with that if you'd like. Okay, so it says Lori is 4 years older than 3 times the age of her son Ron. The difference in Lori's age and Ron's age is 26 years. Okay, so we need to figure out an equation that incorporates all of this. And so I'm actually going to do this one a little different because I think it's easier to show you how to do this. We want to get one equation with one variable. Okay, but right now there's Lori's age and Ron's age, and we don't know either of those. So I'm going to let Lori's age be a capital L. I'm going to let Ron's age be a capital R. And I'm actually going to start with the second sentence because I think it's an easier one to come up with an equation for. It says the difference, so that right there should tell you subtraction, in Lori's age and Ron's age is 26 years. So that should give you L minus R equals 26. So we've done an equation for that second line. Now we need to come up with an equation for the first line. And it starts off with Lori is. Remember, if you see the word is, that's an equal sign. So it should be L equals, and then it says 4 years older. So older should be addition. So 4 plus 3 times the age of her son. So 3R. So our second equation should be L equals 4 plus 3R. Okay, so what good did that do? Well, we now have 2 equations. We do have 2 unknowns, but we can do a substitution here. We know L equals 4 plus 3R, so we can take that and plug it into the other equation so that we get one equation with one unknown. We can plug that into the L minus R equals 26. And anywhere there's an L, we're going to put the 4 plus 3R. And so that'll give us 4 plus 3R minus R equals 26. So right there we have one equation with one unknown. That is something we can work with. We can easily solve that in order to find out what's Ron's age. And then once we know Ron's age, we know what Lori's age is. Okay, so let's just finish working through this problem. If we have 3R minus 1R, that'll give us 2R. And if we subtract the 4 over to the other side, that'll give us 22. So we get 2R equals 22. Divide both sides by 2, and we get R equals 11. So Ron is 11 years old. Now, we need to figure out how old Lori is. It says Lori is 4 years older than 3 times Ron's age. So Lori is 3R plus 4. We know R is now 11, so let's plug that in. So we get 3 times 11 plus 4. 3 times 11 is 33. Plus 4, that'll give us 37. So Lori is 37 and Ron is 11. Your homework may ask you just to write out the equation, or your homework may ask you to solve. Like, you have to come up with the equation and then tell us how old Lori and Ron are. So I just wanted to make sure you understood that. The next example is a tax equation example. There is a question like this on like every test that's going to have word problems. And it's on the final. It's always on the final. Because this one is one that you're going to be able to use in everyday life. And it's also one that can trip up a lot of people because it has sales tax in it, which can be confusing. So let's work this one. It says Kate bought a new car. The cost of the car plus a 9% sales tax was $20,000. Okay, so we need to write an equation for that. It doesn't sound like a lot of information, but there's actually a lot there. So I'm going to use C as my variable since we're doing the cost of the car. And it says the cost of the car, which is our C, plus, so let's put a plus, 9% sales tax was or is $20,000? Okay, so it's the 9% sales tax that could mess some of you up. When you take percentages of something, you have to multiply that something. So the cost of the car, we have to apply the 9% sales tax to. So that means we're going to have 0.09C. Because we have to take however much the cost of the car was, take the 9% of that and add it to the cost to get our $20,000. So our equation should be C plus 0.09C equals $20,000. Okay, this is one of those times when I wish I could see your faces to see if you understand why this works. I'm going to try and describe it in another way, and maybe it will help you. When you go to the grocery store and you're making your purchases, you get a subtotal at the bottom of your check, and that is like your cost of your car. You get a subtotal, and that's before taxes. Then if you look at your ticket, it's going to say, your sales tax, and what it does is it takes the 9% times however much your subtotal was, and then you add that to your subtotal to give you your eventual total. So that's exactly what we're doing here. We have the cost of our car, then we have to take 9% of that and add it to the cost of the car in order to get the $20,000. So hopefully that clicks, because I know we buy more groceries than we do cars. So we do actually see this. Okay, let's go ahead and work the problem out just in case. If we take C plus 0.09C and combine those two, we're going to have 1.09C equals $20,000. If you then divide both sides by 1.09, you're going to get C equals 18,348.62. So the car actually costs $18,348.62. But then when you add in the 9% sales tax, you're going to have $20,000. Okay, let's do the very last example. And this one is a multiple choice one. So it says Ellen walked 4 miles less than 3 times as far as Kate walked. And we said that that's going to be W. Together they walked a total of 10.8 miles. So we have to choose the correct answer. So over here on the side, I'm going to write some notes because I think this one's easier to do with 2 equations, 2 variables, and then we do a substitution. So let's start with the second line. It says together they walked a total of 10.8 miles. So if we add how far Ellen walks with how far Kate walks, we will get 10.8 miles. So I'm going to let E be how far Ellen walks, and it says W is how far Kate walks. So if we have E plus W equals 10.8, that's our whole second line. Now, the first line says Ellen walked 4 miles less than, so right there that should be a -4. That should tell you -4 because it's going to be subtracted from something else. And it's 4 miles less than 3 times as far as Kate walked. So Kate walks W. So if we take 3 times that, we'll have 3W. And then if we subtract 4, we'll get E. So that's E equals 3W minus 4. Okay, so now we have 2 equations, 2 unknowns. And you're probably looking at these thinking, that looks nothing like A, B, C, or D. So let's combine these so we have 1 equation with 1 unknown. If we do that, we said that E equals 3W minus 4. So right here where there's an E plus W equals 10.8, let's plug in 3W minus 4. So if we do that, we'll have 3W minus 4 plus W equals 10.8. Now, does that look like any of our examples? Any of our answers? Yes, that is the exact same thing as B. And that would be the equation that we would use. We could continue to solve this and figure out how far Kate walked, and then we could figure out how far Ellen walked from them. So I just wanted to make sure you could just pick out the right answer from this problem. Okay, again, this whole last page was just problems off of your homework, so I'm not actually going to open up your homework and do any for you. I hope this handout helps. I hope the little tables help, so you can be able to read through the problems and get them done. So good luck on your homework and good luck on your quizzes.